Bismillah ar-Rahman ar-Rahim. Good evening. Today at this video, we will try to talk about sol gel. I'll try to do a simple review on sol gel by using some important information and some important pictures from my study. Let's go to next slide to take a look to the contents. Actually, I will focus on these five first contents: introduction of sol gel, how many kinds of sol gel we have, which one I used in my study, steps of sol gel, all of these five steps, and go deeply on it, advantage and disadvantage of the sol gel. Let's start from the by taking historical idea about sol gel. First works on sol gel from the mind 1800 century of all of these two scientists, L. Bellman and Garham, on the fabrication of silica gels. After that, huge numbers of development of the sol gel technology are started. Why? Because it has many advantages. We will talk all of these deeply at the next slides. The sol gel method became a popular route to fabricate bulk glasses and ceramics. Actually, I used it to produce bulk ceramic. The sol gel process is a scientific procedure involving a transition of, from its name, sol gel. We have two different steps. First one is solution, after that, gelation. System from a liquid sol into a solid gel. Actually, gel is not just a solid, it's all of the sol, liquid, and solid. We will study that at next slides. The sol gel chemistry involves two distinct phases, like I said before, solution and gelation. A sol, what is a sol? Is the first transition in this process is a colloidal suspension of solid particles. After that, gel will happen. It's an interconnected network. Actually, we can say 3D interconnected network of solid phase. Like I said before, it's content of the liquid and solid phases at the same process. After that, we will use the temperature to disappear solvents to make at last step powder. Like I worked in my study to more classical industrial technique for glass and ceramic manufacturing, which require very high temperature. Like I said before, but we will not use high temperature suddenly. It will be step by step. Here's this picture, this plot, no, it's not plot, this picture is more specific, illustrate to us how much sol gel publications increased. At last 10 years, from 2010 to 2020, it's in the publications are increased to more than 1,500. After that, the sol gel method involves the use of colloidal solution, like I said before, sol that involves into gel-like network, including both liquid and solid phase as a result of several chemical reactions. We will take a look to the several chemical reactions. It can be divided into two types, aqueous, or we can say hydrolytic. Actually, in my study, I used this one, aqueous or hydrolytic. That's mean I used water as an important solvent, and non-aqueous or non-hydrolytic. Here, this picture illustrates to us the important steps of sol gel. At first, dissolve from precursor. At the first, we put it the solvents. It's organic or non-organic. That depends on your study. In my study, I used inorganic. The solvents were water and hydrochloric acid. All of these are uh, non-organic, and I use the precursor to do my dopant process to produce doped perovskite oxide ceramic with, let's say, better uh, electric and magnetic properties. Here, after that hydrolysis, the reaction between solvents and precursors, it's happened, condense to start to convert from salt to gel, from solid to from colloidal solid to three-dimension liquid and solid phase to be gel. After aging process, we will achieve the 3D network gel, okay? Colloidal of solid particles at sol at last state of gel interconnected network of solid phase particles, or we can say 3D network particles of solid and liquid phase. Because that we will use treatment, the temperature treatment to can disappear the liquid phase in this gel to can achieve extra-gel. We will focus on it at next slides. Here, the extra-gel, like I said before, it's another picture. Actually, I used it, I put it in my thesis. It's helpful. Illustrate to us all of these 5 steps of sol gel. First one, the hydrolysis, when I put it all of the precursors plus solvents. Solvents, like I said before, it was pure water and with hydrochloric acid. All of these were inorganic solvents plus precursors. Precursors was titanium manganite hydroxide and manganese nitrate tetrahydrate, and I doped this process by using specific amount of calcium and strontium, because that I use calcium manganite tetrahydrate. Yes, like I remember. After that, the salt formation, it's done. It's a solid phase interaction between all of these, the precursors and the solvents, it's happened. That means some attack of oxygen will be on the metallic oxide, because that we use the water as a solvent, because we will take the oxygen from it. After that, let's talk about the gel, the 3D network, so liquid and solid phase. At this stage, it's gel by using sintering device with a magnetic fish to make this stirrer process be better with increasing temperature a little bit. Actually, in my work, I increase the temperature, increased by depending to increase the temperature 50 temperature Celsius. I increase the temperature by this way. After that, I will have the exorigel, and now at exorigel, we don't have solvents. Why? Because the temperature treatment. Here at, like I remember, less than 300. After that, I increased it to more, like at this picture at the gas room. It was approximately 450. You can have the final products. Final products will be like carbon. Now let's talk about each step deeply. Hydrolysis. Here the metal haloxide, or can say Ma, metal oxide. That means the precursors, like I said before, manganese nitride tetrahydrate and another. And solvents, all of the water and hydrochloric acid. And you can use another if you want. I used inorganic solvents, like I said before. Then an attack takes place. Which attack? Oxygen attack takes place on metallic oxide by the oxygen from water. As a result, continuously removal of L-oxide function, functional and formation of alcohol functional group, MOH occurs. Here the scalar I used is to calculate how much, specifically, how much amount grams I need from all the precursors. Actually, it was long math functions. I will do a video to illustrate all of them at these next few days. Here, hydrochloric acid, the solvent, inorganic solvent. I use this tool to take how much amount I need. It was 25 mil of hydrochloric and 50 mil of water. Here, all of these amounts is very critical because that we must work on long math equations to can find the correct amount of them, because if we increase or decrease some one of them, the result will be different. At last, at this glass, the solution, it's, we can say, like a milk with this tool, glass pen, to stir this liquid to make the interaction between them be better, to make the oxygen attack on the metallic oxide be better, to can achieve alcohol functional group, MOH. Here, these particles in solution are much smaller than 1 micrometer. I take this information from one of these sources at last slide. What that's mean? That's mean it's optical. We can say it's because the wavelength, it's equal of the wavelength of the light. These particles are normal optical particles. By that, we can't see it by using microscope. Here, Sol is not happening yet. The most important factor is gelation ability, when all of the solvents and salt solute particle have ability to bond on each other, to can have new chemical bonds, new chemical compound. After a certain time, gelation occurs because of the chemical reaction and electrochemical interaction occurring in the solution. Like I said before, when I was talking about interaction, chemical interaction, here we have notes. The oxygen partial pressure plays a crucial role in the nanoparticle formation under hydrothermal conditions. I worked on at room temperature. I used water, like I said before, 50 milliliter and concentration of hydrochloric acid. It was 25 ml with the specific molar ratio. Like I said before, this specific molar ratio, they were critical, because that I will illustrate how I can find it, and I will focus more than on the precursors and how I can find it. But the specific ratio about water and hydrochloric acid, it were very important. If increased or decreased some change will happen on the last product. Here, and let me don't forget another important note. Water here, advantage of water and this interaction to two things. First one, I said it, the oxygen attack will happen on the metallic oxide to can achieve the alcohol metal MOH. And the second thing, water will act here as a medium to the interaction. Here, the condensation, or we can say polycondensation, but I prefer to say condensation state is associated to the formation of polymer network, polymer network made of metal oxide. Linkage as a result of elimination of solvent, water or alcohol. That's mean I will increase the temperature a little bit with stirrer process will keep going with temperature increasing from 50 to 50, for example, 50. Actually, here I started from 100, 150, 200, and goes like that. The process increases the viscosity of the solution. Let's take a look. Here at first, it was like a milk. And by increasing the temperature and the stirrer process keep going, the viscosity increased. And the another pictures will be clear more. What does mean? That's mean water and alcohol, water and hydrochloric acid will disappear state by state with increasing the temperature. The solution as a polymer network growth. What does mean? That's when we will start to produce gel. Because what? Because gel, it was a polymer network growth forming a porous structure. At gel, we have porous structure within the liquid phase. That's mean here gel is done, is obtained. Here, hydrolysis and condensation, all of these two first stages, reaction are strongly affected by process parameters such as temperature, pH, the ratio, the concentration of water, how much milk I put from water, I mean, and all oxide functional group use aqueous or non-aqueous media, organic or non-organic solvent, the ratio of metallic oxide, I will explain it at next video, concentration of catalysts. What is this catalyst? It's in my study was ethylene glycol and citric acid. It's acid. Here we have notes when we use catalysts as base, the process will be faster more. But I use citric conditions because that it was slower a little bit. Not a little bit. Here, the third and fourth state, the aging and drying state. Precipitation of gel, dropped off gel network will happen, which decrease the porosity and increase the thickness between colloidal particles. Here, it's clear when increase the temperature. The colloidal is increased from a little bit like liquid to be like, let's say like a honey. It's colloidal particles. And let me keep going, increase thickness between colloidal particles like this picture. And during increase the temperature, here approximately to 300 Celsius, the evaporation process is happened. By that, we have exerogel formed, like foam from liquid to honey to be like food. That has substantial impact on gel structure when the liquid is removed from the gel. Major change. What does mean liquid? It means the solvents. From gel, major change to the network structure may occur and extra gel is formed. Here at this form, we don't have solvent yet anymore. Why? Because the temperature treatment. Here, the calcination. That's mean I have aerogel form like foam at last picture. That now at aerogel I don't have any solvent yet because the temperature treatment, but I must increase the temperature more. Here I will use this furnace to can achieve product without agent, without hydrochloric acid, without ethylene glycol. And I will explain at next slide why we use it. Because to dealing with some advantage in sol gel, this disadvantage is the cracks. Now let me come back to this slide. Calcination, that means heat treatment, increasing temperature. By using the furnace is important for drying gels. Drying gels from what? From the agent, from the agents, citric acid and ethylene glycol. Densifying the material to produce ceramic or converting to crystalline. Here, these are very helpful pictures to can create a good imagination about this process. Here, aerogel, like food, when increase the temperature more to be approximately 450, we have black material like carbon, black like carbon. Here, the agents started to disappear, but to be sure that we don't have any solvents anymore, we will put this material inside the furnace to 24 hours to can reach their room temperature again. The temperature will be 600 Celsius and the last product will be like that, just like carbon, without any solvents, without any agents. Here, after that, I take from the furnace, I used aluminum foil, nylon and aluminum foil. Why? Because one of the important disadvantages of the sol gel was sensitivity to moisture in the air around. Okay. The last product like that at 600 Celsius, we can say now the perovskite ceramic oxide is approximately prepared because that I have on that just crushing these powders to decrease the distance between atoms to can achieve a bigger atom from this product, and by using the pressure to can produce my doped perovskite oxide ceramic. To use another temperature, can say here it's sintering temperature. In my study, I used two different sinteric temperature. First one, it was 900. Second one, it was more than, it was 1100. Actually, I used 2300, but the my tablets molted up. That's mean it's disappeared and lost it because that I will focus on just the 900 and 1100. Here from another source, from another article, Sneeves and his team examined the principles behind soldier process such as precursor selection, formation, gelation mechanism, and factors influencing the final properties of synthesized nanomaterial. Here it's important, this method produces pure crystal perovskite. Because that I used it at temperature close to 1000 Celsius. At about 600, crystalline perovskite structure appeared all at once, immediately. 600 from another sources, it was very helpful temperature, and the 1000 Celsius, it was from another source. Uh, by using it, we can produce our pure crystal perovskite. As the treatment heated up correspondingly, what does mean? By increasing the temperature, when I increase the sintering temperature, that's mean the crystallinity degree increased. To modify the characteristics of the final perovskite material, a variety of dopant, I used it, and additives, I used all of them to can produce new perovskite oxide ceramic with better characteristics. Okay, can be added during sol gel. I added all of this. Doping was calcium and strontium, the specific amount. Additives was the agents and solvents. Manganite, why I selected lanthanum manganite oxide and I doped it with calcium and strontium. Let's discuss about that. Manganite is most appropriate addition and is frequently employed to customize the physical and magnetic properties of the material. By that, I selected the manganese to be my transition material in my this doping function. A1 minus X, BX manganese oxide. Because manganese has a three different valence states, 2 plus, 3 plus, 4 plus. It's the main reason to be it very important in a process like that. It has three different valence states. It has been determined that certain compounds containing manganese may find use in functional device such as spintronics. It's a medical field, to select and dealing with Allah person cancer disease, electronic material and magnetic media and more than. In addition, a great deal of research has been done on manganese-based compound with various valence state because it has different valence states. Ferroelectric property, it has another advantage. Ferroelectricity property, high magnetic dielectric effect, ferromagnetic isolating behavior. All of these advantages because it has various valence states. Here I take this picture and this information from another article. Figure 1 shows the diagram of the sol gel. Like I said before, and like the last picture about sol gel steps illustrate to us, we have different kinds of drying. Actually, I use drying by increase the temperature. but you can drying the product by using freezing or superconductor drying. It's another process to drying your product, but I used drying by increasing the temperature. Two can achieve exerogel, not another phase, not another compound. Preparation of the solution of precursor, hydrolysis and partial condensation of alkoxide to form a cell. Here illustrate to us the steps of the sol gel. Formation of the gel, polycondensation of hydrolyzed precursors. Here drying the gel forms a dense exerogel like my work. Collapse of the porous network, decrease the porous network number, cased by evaporation. I used evaporation process to can achieve exerogel with less than porous network number, cased by the evaporation of the solvent, like written there, or an aerogel. It's another by using another drying. Example through supercritical drying. It's not my topic. Atlas calculation to obtain mechanically stable material. Now let's talk about the advantage why this method is entranced. It's very important compared with other methods like solid phase reaction method. Possibility to obtain special products such as powder, like I worked on it, and you can produce another films, microspheres, like you want, obtaining new solids, like I did, with improved properties, high purity and homogeneity of the material, saving energy, full control over the particle size. It's very amazing here. Actually, we can increase the particle size by using this process to be maybe more than 10 times. Full control over the particle size and morphology, the solution and reaction will be, we can produce uniform doping at molecular level. Compared with solid phase reaction, it's very commonly to produce solid perovskite oxide ceramic. It needs temperature less than 220 Celsius. By that, it's low cost. But at any method in our life, it has drawbacks, or we can say disadvantage. Extremely sensitively to moisture, because that I use the nylon foil film. Hard to scale up, consuming time because it's requiring multiple steps, changing in size and volume as it goes through different stages, because that you must be familiar when you're dealing with sol gel process, creating fracture when gels dry. At next video, we will talk about the fractures, why it's happened, how we can deal with it, how I could deal with it, and some amazing information will be at the next slide related with sol gel and how we can produce perovskite oxide ceramic. Thank you about your watching or listening. Have a good day. See you at next video. From where I can close it.